And I think the bar is much higher for that final round. Like instead of half a day of programming to build something, it's a full day. Engineer day look like for you in the age of coding agents?
Open source is at risk right now. Cal.com just said open source is dead. Why is TensorZero still open source in the age of AI?
I think like if your security model relies on your code being obfuscated, you're telling yourself a fake story.
We hired a Rust maintainer. Why Rust specifically?
There were all kinds of things that we did wrong the first time. He came in knowing so many tricks. Rust really hit me hard as a great programming language a couple years ago when I picked it up.
The scaling hypothesis talked about how we need more data and we need more compute.
It seemed like pre-training is sort of back with a lot of compute has come online in the last 6 months. That points back to continued juice to squeeze out of scaling.
I'm here today sitting down with Viraj Mehta, our CTO at TensorZero, with a PhD in reinforcement learning and robotics at CMU. TensorZero is an open source C-stage AI infra where we raised $7.3 million. We've been building in stealth and now open source software for the last 2 years. Really excited to have you on our inaugural pilot episode.
Yeah, I'm happy to be here. I'm excited to share.
Okay, I'm Michelle, the new developer relations. So first, we're going to start off with hiring the age of AI. So I think the existential question that every single software engineer is facing is that Claude Code has essentially solved all of coding, implementation is solved. So as a CTO hiring for the founding team, what else are you hiring engineers for? What are we still good for?
Yeah, I think it's a great question. One thing that I like, as the models continue to get better and implementation continues to be, more and more solved, I think what we really need is the ability to understand the context in which any piece of code sits. There's the whole software development life cycle really matters here. So going from, okay, there are requirements or users have requests into, all right, there are features that we may want to build. There are infrastructural changes we need to make. And then, okay, how does this actually get broken down into individual pull requests and diffs and so on? And then as those come back up through, review and testing and so on, into the product, it affects kind of the velocity in the future. And so taking the holistic view of developing software, you have this question of how does my change deliver the desired feature, which is of course the part that Claude has most solved. But then there's this question of, has this change disproportionately increase the complexity of my code base in the appropriate sense? And will it make it easier, harder, or the same to develop features in the future? And is this adding debt or complexity to our code base? And I think those questions about first, taste around what features to build, and then second, how do we make the code base as simple as possible so we don't have to deal with stuff in the future are the questions where we really still need human engineering judgment. I do think the models and the agents are getting better at especially the okay, here are a bunch of options and I think this one might be the least complicated. But I think that the really long horizon questions of how will this shape up in the context of where we're going are still quite human.
Then how do you hire for this and how do you test for this in your engineers?
Yeah, so we've changed our interview process a good amount over the years as coding agents have come online. We started with 2 coding rounds. We had a final round that was more of a smaller project. It was a half-day thing, and it was designed to really understand can people write code, can people own code, and so on. I think that has changed dramatically as we've moved towards a world where implementation and typing on the keyboard, typing the symbols for the coding language, doesn't matter as much. And so now all of our interviews have our coding interviews still do 1, mostly because you still need to read and understand the code. And so we want to, I think writing a little bit of code is good, but the interview has changed. So it's a lot more conceptual and it's a lot more about, can you make a conceptual couple of hops and leaps rather than so much about actually implementing and dealing with some of the details of coding. And then for the rest of the interview process, we talk more about systems design and how kind of the scope of the systems you build. Like we talk about more of those kinds of questions and more of the like outer loop questions of software engineering that we did in the past. And then the final round, we have raised the bar quite a bit. So instead of half a day of programming to build something, it's a full day so that we can really see kind of what can you get done in a day. What does a engineer day look like for you in the age of coding agents? And then I think the bar is much higher for that final round. Like we expect people to build a lot more software than they would have in the past. We expect people to kind of have some taste and like some ownership over the decisions that were made along the way in terms of how they build. And I'm really looking for somebody who, by this point, like you should have tried the agents, you should be familiar with them, you should probably have opinions about how to use them well. And so I also want to understand for an engineer, like, have you learned how to use these tools well? Because now, like, if you haven't, you're going to be far less productive than someone who has.
Yeah. So I remember when I came in for my interview, I had the full day. I was on Claude Code for 8 hours, and I remember I hit all my session limits as well. But curious to know, for someone who's now looking for a job or a new grad, what would you recommend for them to get up to this new hiring bar?
Yeah, I mean, definitely, like I said, use the agents, use them heavily, use them for personal projects, use them for things that you're not familiar with, use them for things that you are familiar with. I think both of those categories are very, very interesting and educational. If you use a coding agent on stuff that you know really well, then you might catch some of the deficiencies that are still there and like know kind of, okay, what do I need to look out for on a code base that I really understand? And then also, I think using a coding agent for something that you have very little background on gives you a sense for, all right, like what is possible if I need to go fast? Like what is possible here without, me being careful about like code that I write. I think there are really two modes of software engineering, and like, by suggesting those two things, I'm kind of pushing a new grad or a junior engineer to learn about both of them. One is like, all right, like I want to see like what's possible here. I can kind of sketch in pencil, but like really, really fast. Like how might this system work, and like what are possible design shapes for it, and like can I go as fast as I can? And this is common in startups. And then we build system software where a lot of developers depend on our stuff, so we also have to be careful. And so our stuff is more in the latter camp of like, okay, we want to build the best software we can. And so to do that, there's the other camp of like, let me be really careful and work on something I understand and like see where it is. But, even among that, like I build both kinds of software all the time. And so I think there's a lot of value there. One other tip I would suggest is, to go when you have a dependency that you want to use that you haven't used before. I think like the docs almost are less useful than they used to be, because you can just grab the code, stick it on your laptop, go to the folder where your project is, and then say, I want to use, TanStack start, which I did recently. I hadn't used it. Let me just clone TanStack start. The docs are in the repo. All the code is also in the repo. Tons of examples are in the repo. And then just say, okay, like, here's your reference material. Here is the thing I want to build. Let's plan out together how this should work, and then kind of break this project into little milestones, and then build it out. And I think like that primary material of like reading the source code of a dependency is something that I would never have really done, except for in very special situations before, and I would have relied heavily on documentation and trial and error. But now with an agent, it's like, okay, well, there's the code, go get it.
Yeah, that's super cool that we can all understand the source code now.
Yeah. I recommend people do this with TensorZero as well, because our code base is laid out for this. We have tons of agents files everywhere, and like try to document in source and write a lot of tests and have a lot of examples in the code base. And so I think it's quite a good code base for a coding agent to go look at and like understand. All right, how does TensorZero work?
Yeah, I think one of my interesting fun facts with our hiring process is that we hired a Rust maintainer.
Yeah.
And I want to ask, first of all, like, why Rust specifically? For the people who don't know, why does it have such a good community? And what does the unique skill set that a maintainer might bring that like the 10 junior engineers can't? And how does it tie into everything you just said?
Yeah, and we're really grateful to have Aaron on board. He's amazing. So I'll talk about Rust from my perspective. I'm sure he'll bring a different perspective in another one of these interviews later on. But for me, I actually came to Rust from like mostly a lifetime of writing mostly Python, though I'd written some C and C++ and Fortran and other things. Rust really hit me hard as a great programming language a couple years ago when I picked it up. A couple of reasons why are, I think the type system is very well designed. I think algebraic types, when that clicked for me, I really was able to express a lot more about how my data looked in a way that I hadn't before and was doing kind of sloppily in Python the whole time. So that type system, the ability to say, okay, this variable will either contain a particular thing or it will contain nothing, and Rust forces you to handle both of those possibilities every single time, means that you'll never get a none error or a null pointer exception or that sort of thing, which I think is quite nice. Forces you to kind of explicitly reason through the code. Similarly, with the result type, every operation that is fallible can be handled, and it forces you to think about the failure cases very early on if you're writing, safe production code. So I think both of those types, the ability to write code that is kind of as fast as computers go, more or less, while having a lot more tooling available to you than if you were going to write C or C++, at least C, and nicer tooling, I think, than C++, is very nice. So when I write a Rust program, I know that I am aware of, all right, like here are the places where I'm doing bad things with the computer to save on time. And if I wanted to, I could go back and remove all those things. And I'd be pretty close to as fast as computers go with, modulo like the final effort that you would have to make. And so I think Rust is great for that. And then finally, concurrent programming is critical today, I think, for all network applications especially, but like today all computers almost are multi-threaded, and we expect for performance to have lots and lots of cores available to us. And so Rust has a great story around concurrency compared to the old C family of programming languages and something like Python. And so very, very happy to be able to kind of just trust that the Rust ecosystem in Tokyo will be well designed for our gateway especially, which is like fully a network application. So I think to summarize, I think Rust is incredible. I think it's the strengths, and I didn't even talk about interoperability. I'll leave that for another time. The type system, result and error handling, and performance, safety, and concurrency are all great.
Absolutely. A lot of our first users came to us from open source Rust. We had a Tokyo contributor. We had all these contributors. So Rust has really built a fantastic community. But next fun fact, you're saying we hired a Rust maintainer.
Yeah. So when we learned, I think it was really cool to learn Rust like 2 to 3 years ago. It was right before language models got good at coding. And so I had to kind of bang it against it with my head, painfully for a while. And the compiler, like in the very beginning, it's like, what is happening and where do all these symbols go? And like, where does the lifetime specifier go? And like a lot of things that you don't think about anymore when Cloud Code does it, were quite like complicated in the beginning. And so I felt like I got a very thorough understanding of Rust back then, except for the fact that the rabbit hole goes really deep. And so I was writing application level Rust, and then once in a while I would like touch on the depths of the language and be like, I'm going to need like some help here. And, let me just work around this in a way that's possibly suboptimal. And turns out, like, besides that, there's a bunch of coding style stuff for Rust that, of course, matters a ton. And, Aaron showed up. He'd worked in, I don't know if it's the largest, but the most fundamental Rust code base in the world, Rust itself. And so he came in knowing so many tricks about how to build like a hygienic code base, how to build a more correct and like simple code base, how to prevent other programmers from making mistakes in Rust, how to use the compiler to our advantage to make sure that like the programming patterns are what we think is like correct across the board, how to make Rust talk to Python, how to improve performance in lots of ways and stop copying so much code or copying so much data. There were all kinds of things that we did wrong the first time that, learning from Aaron on how to do it correctly helped us with. And he was like our first full-time engineering hire. And so we were really lucky to be able to have somebody like that who showed up and was ready and excited to write open source Rust and cared a lot about developer tools and then was able to really take this project to the next level. And so very, very grateful to have him on board. And I think learning from somebody like that has really definitely improved my own programming in general and especially in Rust.
Yeah, for sure. I think that goes back to the point about how AI cannot write clean, hygienic code base.
Yeah, I mean, it's gotten better though. It's getting better. I think a local unit of code is now very clean from an AI, but then to think about like, okay, how does the bigger picture fit? How does it fit into the bigger picture? How does it fit into the bigger picture? How does it fit into the bigger picture? And like, you keep kind of the scope of what an AI can do increases, but then like, okay, that means the scope of what we can do as developers also increases. So we have to then think bigger.
Yeah. I think the next question is, open source is at risk right now. Cal.com just said open source is dead. If you saw that. And then today we had a freak out over the Bitwarden crisis. So why is TensorZero still open source in the age of AI? Why do we stand by this decision?
Yeah, I mean, first, it would be impossible if I had, going back to my earlier point about get the source code, go look at it, like figure out how it works, and then make it, integrate with it. That is impossible if your code base is closed source. Then you're like, hamstringing your users who you want to integrate with to rely on documentation. Cal.com ultimately is like a calendar app, right. So maybe they don't need as much interoperability and integration and programming and so on. But like for us, we're a developer tool, we're infrastructure. I think it's very critical that we're open source. The reasons why, besides that one, are I think like if your security model relies on your code being obfuscated, you're telling yourself a fake story. If you look at some of the writing about Mythos, and I know that it's able to from either a compiled artifact or from like a public API surface reverse engineer what's going on under the hood and then find vulnerabilities. This is not like a fake magical thing, but like it is documented in their cybersecurity report. And so all the back when I learned about computer security and cryptography for the first time in college, it was clear back then, and I think the professor was very clear that like just because your code is now a secret, it doesn't mean that your system is secure. And so you have to design systems from first principles that don't have these security vulnerabilities. I think with open source software, you get the other benefit of, hey, like TensorZero has been open source for a couple of years now, or a year at least. And I'm sure there are like issues with it, but at least like we have a lot of eyes on the code base, looking it over, trying to find vulnerabilities and like noticing how auth works and how credentialing works and the stuff that is security related, like how that stuff works. And so we the longer the TensorZero stays open source, the higher the probability is that the code base is bug free. It's not perfect. There are long bugs in old code bases that Mythos has found, but I feel that like being open source and transparent means that over time, like many agents will have looked at this code base and tried to find issues with it, and they won't have been found. Whereas for something like Cal.com, which will be now closed source, it's only their agents, whereas like everybody's looking at this.
Yeah, that makes sense. Do you have any hot takes about how a lot of the open source projects have faced vulnerabilities or why that might have happened?
I mean, I'll go back to the Rust thing for a second. It's a lot easier to feel good about your security posture if you're writing Rust because at least the memory category of bugs of, use after free or, offset from an array or some of the like those sorts of things aren't happening. I don't want to invite people to come and try and cause problems at TensorZero, but I do feel good about the security service from that perspective. Another thing that I would say is like it is, I think like we try. We're not perfect, but we try hard to also think about kind of the supply chain of our software and like what dependencies are we taking, what GitHub actions are we using. We actually work across the hall from the guy who made Zismore, which is the static analysis tool for our GitHub actions. And so we've been trying to, do better and better there to make sure that like somebody couldn't publish malicious software through our supply chain. Somebody couldn't get malicious software into our dependency stack. And so we're always trying to like make sure that things are pinned and stuck and like locked down and careful. And, we'll continue to make that a priority.
Yeah, absolutely. So I want to move now into AI infra. One of the problems we faced is that everyone talks so much about using AI and LLMs, but really like we're in like a toddler Stone Age era of AI infra.
Yeah.
And they're just figuring out how to route their models and they're just, kind of like mishmashing together their own like LLM gateway. And so I think we're accumulating a lot of technical debt. What do you think is like, what are your predictions for what will happen? Like problems that we're not seeing? What do you think will come back to bite us 5 years down the road?
Yeah, so I think there are a few points of view on what infra is necessary or what infra is required. I think first, like the developer paradigm changes so fast. So like a year ago or two, the lang chain era of LLM engineering, as it started of chaining calls was kind of the paradigm for a while. It feels like today everybody is building around Claude Code or around Codex or around kind of agents that kind of take care of the whole tool calling loop for you. And in the future, it might be that we have, many agents, or we go back to software that agents write that's like self-driving, or, the software modifies on the fly, or generated software, or, there are like a lot of different form factors for what software might look like. So I don't want to say that like people are bad developers. I think the rate of change here is such that things haven't had time to cool down and consolidate. I don't really anticipate things cooling down and consolidating too much in the near future. But what I do think is true, I think is like axiomatically true, is that at least large organizations are not going to want to give credentials everywhere and like people doing stuff, and they're going to need some controls and some observability on what exactly is happening with AI tools across their org, and like what exactly is happening with AI requests across their product, because there certainly is the possibility to spend a lot more money and like do a lot more crazy stuff than was possible with like pure software in general. Second, I think that people at least ought to, and I think in some cases, like larger companies, of course, do want to maintain leverage in the negotiation that happens with Anthropic or OpenAI or whatever every year or whatever, when they're trying to decide, all right, how much should we pre-buy for our tokens or whatever for the year. And the reason is like, if you completely lock yourself into, not to pick on Anthropic, but Anthropic's ecosystem, you'll have this, when it comes time to buy tokens next year, maybe they won't be as subsidized, the discounts won't be as good, and you'll have this question of like, how do I, can I like get rid of this line item in my cost center or whatever? What if I, want something a little more customized or a little smaller, a little cheaper, that kind of thing? And so I think it's nice to retain optionality around these models. And the way that you do that is you keep track of, okay, everything that went in and out of Anthropic over the last whatever period of time, and did it work well for my business? I think those two things together allow you the opportunity to then think about, should I be training my own model? Is OpenAI better? Are these open source models competitive? What if I fine tune it? Could I just improve this by like getting an open source model and giving it much better instructions? All of that is possible if you know what went in and out of my models, and then crucially the consequences for your business. And so being able to basically join those two tables means you have a bit more leverage against an Anthropic, not to pick on them. And so, I expect like larger enterprises to continue to care about this.
Okay, cool. So I'm hearing that you're saying that your predictions that people care more about like interoperability and optionality and things like that.
Yeah, I think it's like controls, like the things that I'm sure will happen are controls will remain important because you have to. I predict many people will care about these two tables and being able to join kind of inferences and feedback. And then the actual application code part of the product to change very, very rapidly from here until years from now. Because I think the models keep getting better, more capital is spent on training and stuff, and like the scope of what you can build gets bigger and bigger and bigger, and we want to kind of move faster and faster and faster. And so besides kind of observability controls, there's a lot that's going to be moving around in the middle. We hope to, build some cool stuff there too.
Yeah, cool. Yeah. Next thing I want to revisit is the scaling hypothesis.
Sure.
The scaling hypothesis is a paper that came out in 2020, right when GPT-3 dropped. And it basically blew up in the recent years because it talked about how we need more data and we need more compute and how we're going to scale and hit AGI in 2027. Mm-hmm. But we're 2026 and we're pretty close, like, I don't know if we're close, but Claude Mythos came out. We're probably better than what the scaling hypothesis predicted. So I'd love to revisit that paper in here.
Yeah, well, I think the scaling hypothesis is part of a long and shockingly prescient tradition of, futurists looking at like how fast computers were getting better and how many computations we estimate happen in the brain, and being like, okay, well, these lines cross around 2027. Even decades ago. And so the paper, I think like the most exciting kind of pieces since, just for color, where there was, if you have not seen the chart in the scaling loss paper from Kaplan, I recommend you go look at it. Maybe we can like include a link or something or flash it on the screen. Because because it is the straightest line across 10 orders of magnitude I've seen in a chart ever. And, the guys who worked on that paper all pretty much left to found Anthropic, or most of them did. And I think like that paper kicked off what we see today, in that, that demonstration that, okay, like output scale log with inputs kicks off once you think about it. Oh, well, we're going to need like orders of magnitude more money to spend on this thing. And, OpenAI as a nonprofit couldn't raise orders of magnitude more money. So, today OpenAI is a for-profit corporation. And I think that line directly points back to the Kaplan paper from 2020-ish. The conclusions of the paper, I think, are interesting. There was looking back at it today, there was a common line of reasoning that, oh yeah, like pre-training has stalled out, and the models will have to find a new arc of scaling. It seems like pre-training is sort of back with some of the things that I hear from Anthropic and OpenAI about like their pre-training runs. I think there's a lot of compute has come online in the last 6 months. As a lot of the capital expenditures of the last couple of years started to bear fruit, and NVIDIA's Blackwell generation of GPUs has started to be used for these big runs. And it was slower than I think we thought, because there was once the GPUs are in place, people have to spend a lot of time on the software stack, and then the training runs happen and they take a while to get right. And now we're seeing the fruits of a few months later. Okay, the models have gotten massively better in the last couple of months. And I think that points back to continued juice to squeeze out of scaling. Of course, we found other axes to scale with kind of the test time compute and the RL on chains of thought style of training, and so that also has showed up. I think there might be yet more scaling if you run many chains of thought in parallel, and so we'll find more and more ways to throw more and more flops at the problem. But this story of exponentially more inputs lead to linearly more outputs, or whatever it works out to, is seems to be holding up. And it's very, very difficult to predict where an exponential turns back into a sigmoid. It doesn't seem like it's happening right now.
Well, I'm curious. The prediction said that when it came out, it said GPT was making 2 times human errors, and that we would only be able to hit human capability by 2027, which is very clearly not what panned out to happen. So what do you think happened that allowed us to be faster than expected?
Yeah, I don't think so. This was a Goran prediction from the blog post. I think the rate of, the whole economy is now obsessed with AI. The amount of capital expenditure that's gone into it is now a couple % of GDP, I think. Yeah. And a couple % of US GDP is now AI capital expenditure. And the amount of, talent, money, basically talent and money that's gone into it means, and better computer engineering means that algorithmic advances have continued, unfortunately, a lot more privately than they did in the past, but each lab is sitting on a bunch of algorithmic improvements. I'm sure they diffuse among them. So there are a bunch of algorithmic improvements to make on kind of the recipe that Goran was working with and Jared Kaplan was working with back in 5 years ago. And along the way, the data has gotten much better. People pay for tons of data. We pay for better data. The recipes for data have gotten better. And so it's there are all these little places where we can shave off a few points of it can get a little easier, and the effective amount of compute that we get is a little more. And so, a little bit here, a little bit there, a little bit in the data, a little bit in the algorithms, a little bit in the actual, how exactly the matrices are multiplied on the GPUs. The transistors get a little smaller, and all of this adds up to, why is this happening a bit faster than we expected? It's that's the gap.
Yeah.
Yeah.
So almost the authors of the paper did not anticipate that the economy and society would invest so much into AI in the time that it did. and
Yeah.
shaved off all these.
And then like the line that like Jared Kaplan would have drawn was assuming like, okay, the same architecture, same training mix,
Right.
same like holding everything constant so you could do the science.
Right.
And we actually have improved the architecture, the training mix, the training algorithms, the optimizer conditioning, all of the stuff has gotten better.
Yeah, everything just shifted beneath our feet.
Yeah.
So just to wrap up this whole conversation, what's the one hire you tell every AI startup founder to make right now that they might not be making? Or what's one skill set?
Yeah, I think I thought about this question quite a bit. I think like it is, as I was talking about with software, I think with all things, as the like individual tasks that make up your job are more and more tractable to automate, the thing that provides value to a business is then thinking about the bigger picture of how this fits into the business and then stitching together many automated tasks in a way that provides value, and like figuring out how to like get yourself out of the loop as much as you can so that these can run as fast as possible is what provides value. And so I think like I would really hate to say critical thinking here. That would be terrible. So I guess like how, like the question that like you need to answer as to be valuable is like, how do I take the Legos that are available to me and build something that fits into the arc of the business? And so I think perspective maybe is the right
perspective.
Yeah, having a good perspective on like being able to kind of join an organization and gain perspective and then make effective use of the perspective is the most valuable skill that I would hire for today.
Is there an example that you've seen across your team where you feel like someone really had strong perspective?
I mean, I think like at a company of our size, everybody has to have kind of the full scope of the business in their head a little bit, at least. It's hard to like only think about one piece of the product. And so when I think about our business, I think about like the cycle time to do anything is a function of like, all right, well, nowadays I'm gonna get my coding agent to build the code, try the feature, run the test, build the test, do the thing, get it in CI, make sure the test passed there, and then like so on. And so it's like, okay, can we think Gabe spent a lot of time and Aaron spent a lot of time and now Antoine is spending a lot of time on like, how do we shave that? Like, because this is the core loop that the agents use and we use, and like we're trying to ship software. How can we like cut every non-essential piece out of that loop so that the time it takes to get like an iteration of work done is minimized? And so I think like thinking about, okay, well, the business is composed of lots of these little tiny loops. And so if somebody is going to spend time on the iteration loop here, it will provide huge dividends for our business. And like, definitely I was very focused on shipping software and shipping features and like, how are we going to do this? And I really appreciate like these guys having time to like go and actually break out, like, how can we improve the entire cycle time, especially as the agents now drive the cycle. So I think that's an example.
Yeah, that makes sense. Higher level thinking beyond just
and lateral. It's a little lateral when my head was in the focused on like we got to ship X, Y, Z, and W.
Right, that makes sense. Okay, I think last question. Sure. Any final hot takes, AI related or not?
Oh yes. I think like it's really fun to build with AI. You can build like things that you would never have imagined. But I don't know, coding kind of sucks now a little bit. Like I think it's a lot of babysitting the agents making sure that they haven't like done something dumb. And then it's a lot of code review. And there used to be this joy in like, how do I have this like idea that I can write down, but I need to write it down in a way that's like the Rust compiler will understand. And like that part of I can write it in English or I can write it in pseudocode, but not Rust was like a good puzzle. Like I never have to solve that puzzle anymore. It's totally superhumanly solved by Rust or by coding agents. And so I mourn the loss of puzzles like that, and I mourn the loss of like a bunch of other good puzzles that now AI is superhuman at solving. Yeah, it's not that fun. It's fun in a different way, but it's not that kind of fun. Is almost like gone.
Right. I find that I always have a headache by 6 p.m. because I'm like babysitting like 5 agents that are running, and I have to go through so many things that my head I have a tension headache.
Yeah. Yeah. And I'll say like, in my free time, I've been reading a couple textbooks on subjects that I like don't like know. I actually been reading the CUDA programming textbook in my free time a little bit because I was like, I never have actually written GPU kernels. I want to know how they work. I think there's no point in my life where I will ever be able to write a GPU kernel better than AI can. Like, I'm too late. I didn't start, I should have started a long time ago if I wanted to do that. But, that means I can do it by hand, and I can have, the Claude Code set me up a very nice harness in which to do my homework and use some of this great GPU infrastructure out there like Modal to run my homework problems. And I'll learn some, and then I'll do it by hand and I won't cheat. And that has been, when I get the time, which is rare, delightful to go back and do it by hand and learn something and like have the synapses stitch themselves together despite no longer being able to like economically contribute in the activity. And I think like it kind of feels like being a chess player a little bit today, where obviously the superhuman stockfish et al. Will always be able to beat me at chess very, 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 very badly, and so will lots and lots of people. But it's still fun to play and fun to learn and fun to stretch your brain.
Yeah, this is off topic, but I play a lot of Go.
Okay.
But after AlphaGo came out, Lee Sedol, the guy that AlphaGo was playing, quit Go, and he said that he felt like the machine had solved Go and killed the artistry in Go, and that Go has lots of distinct playing styles, but the machine is just like, here's one right move, it ignores all styles. And so I almost feel that. I feel that when I play Go, I'm like in pursuit of the machine now. And so that almost, I think, feels into your metaphor, because now when we code, we're almost in pursuit of like what Claude can do.
Yeah, at least coding is infinitely compositional. Like, you can just, like Claude built this great subroutine. Like, what can I do with this great subroutine? Claude built this great system. Like, what can I do with this system? Claude built this great whatever. Well, how can I stitch that together with other things? Claude will, of course, get better at the stitching too, but then, like, what can I do with that? And you can just kind of continually, like, okay, put it in the box, and what can I do with the box?
Right.
Yeah, for chess and Go, it's a bit tougher.
Yeah.
I think the math community, the math research community, is also dealing with this because I think mathematical research is kind of an end in itself in a way, and it's hard to take all the theorems and put them in a box and step outside the box and look at the box.
Right.
So I hope, I'm definitely like, I love math too, and I'm interested in following that. And so curious how that will shake out as AI gets quite good at math as well.
Okay, cool.